Harry Frank from Red Giant here, and in this tutorial we're going to continue our discussion about the physics section of Trapcode in particular, and we're going to jump to a different physics model which is called bounce. And as you might well guess, the physics model of bounce allows our particles to interact with surfaces and, well, bounce. So let me show you how this works. Let's create a new comp, and this will be our bouncing balls. Now again, like I've showed you, I'm going to use my FT toolbar to create a layer of particular and create a camera. By the way, if you are interested in FT toolbar, this is available from aescripts.com. Just go to aescripts.com/ft-toolbar and you'll see it right there. It's a very incredibly flexible and adjustable toolbar that you can add, and you can add anything you want to it. So let's go to particular here, twirl open the physics section, or switch our physics model to bounce. One of the unfortunate things with bounce is that we lose all those awesome turbulence and spherical fields and wind and all that kind of stuff. But we can do some really amazing things with bounce. So before I do anything, I need to have my particles bounce on something. I need to create a collision event, and a collision event only happens with other 3D layers in After Effects. So I will create a layer to be used as my floor. I want to make this 3D, and I want to put it in a position that is good for our particles to interact with. So I would flatten this out and rotate it just a little bit. Here we go. Now let's put this below the particular layer. And even though our particles are seemingly going right through the floor, but that's okay, we'll fix that in just a second. Before I get too far, let's just make a couple tweaks to the emitter. So I'm going to set this to a box. I'm going to switch this from uniform to directional so that these are actually emitting in a specific direction, and I'll turn this straight down. Now I'll change my emitter settings, and let's expand the X and Y axes out. I'll take the emitter Y position, move it upward so that they have just some time to actually start falling and land on the surface. Now they have an initial velocity, but they're not accelerating downward, which is what falling objects would realistically do. Remember, acceleration downward is due to gravity. So let's turn up our gravity. Now we need these things to bounce. So let's go to the bounce section, and I'm going to define a floor layer. Particular actually allows two different layers to interact, and they're referred to as the floor layer and the wall layer. Essentially, it's just two different layers we're going to have our particles interact with and create a collision. So in floor layer, I'll set this to my floor. This needs to be a 3D layer. And I've got three different options here. I can have particular treat it as an infinite plane. So even if the particles land somewhere out here, they will still bounce. And it's just taking this floor and extending it in all directions. If I set it to the layer size, then particles will perhaps fall outside here. And I can do that by expanding my, let's say, my Y emitter size right there. Let's turn up the particles per second. So some of them will land on it and bounce, and some will fall off the edge. But if I switch that back to infinite plane, then these out here will bounce. I can also have it obey the layer alpha. Now don't confuse alpha with a mask that would be on here. After Effects plugins do not have direct access to the alpha channel of a masked layer. If I want a mask, I would either have to pre-compose this layer or use something that has an embedded alpha like a PNG or TIFF or Photoshop document. I'm just going to leave this on layer size. That's generally what I use. I'm just going to be using a floor layer. Just know that wall layers and floor layers work exactly the same. Now, by default, we have a bounce collision event, which means that particles, when they collide with the surface, let's actually thin this out a little bit by lowering the particles. But let's turn the particle size up. I'll turn the sphere feather down. So when they hit the surface, they bounce. They can also slide. So instead of bouncing, they will just hit it and slide around. I can have them stick to the surface. So this is good for things like snow or perhaps rain, but I think this is more behavior of snow. And you can also have it just kill the particles once they hit the surface. Now this would be good if we're using the aux system to create additional particles. Now I've shown the aux system to create trails of particles behind our main particles, but there's another cool part of the aux system, which is having aux particles emit at the bounce event. So once a collision happens, we can trigger our aux particles. So right now we basically see these colors where the particles are hitting the surface. This is because we have the velocity set to 0. If I set this to a higher value, we'll actually see these particles emit at that point. Let's say I'm looking at this particle. The particle comes down, hits the surface, and is killed, so it goes away, and then the aux particles kick in and have a velocity that shoots outward. I can have more particles per second by turning this up. I can have it inherit the color from the main particles simply by turning that up, or perhaps doing a mix of the two. And I can also have gravity, so even though they shoot outward in all directions, which we can't really control, I can have them then accelerate back down after they emit. And I can also have their size over life sort of trail over time. So this is good for creating rain splashes, that kind of thing. Let's actually turn this particle size down just a little bit. So I have this set to kill. Let's actually switch that back. So let's go to physics, our bounce physics down here, floor mode, actually collision event there, right there. Let's leave that set to bounce. There's a couple properties down here that allow us for, well, controlling the bounciness, the random of the bounciness, or the slide amount if we're actually using the slide collision event. But I'm going to continue using bounce. Now they're all bouncing straight upward because my floor is perfectly level. So I'm going to actually rotate this a little bit so there's a little bit of bounce and down and motion downward. And I'll actually take this bounce and lower it just a little bit. Now I'm going to use a custom particle for this. So I'm going to go to my footage here, pull this sort of glassy ball right here, go to particular, particle type is going to be a sprite colorize. Again, sprites are two-dimensional images that always face the camera. They're always flat to the camera. So in the case of a sphere, we can achieve the illusion of a sphere simply by keeping it straight to the camera. So I'm going to use sprite to colorize. So setting a sprite uses the sprite as is without the ability to change color. Colorize uses the luma information and then adds color on top of that, and a sprite fill will fill the entire alpha channel of the sprite. So I'll use colorize, and let's go to color. We'll say generate a color that is randomly chosen from a gradient, and we can use that gradient right here. I'll use well, let's just tap one of these and then just pick a random color from that. Oops. So I've chosen a sprite colorize. I haven't actually chosen what the sprite is going to be. So what we're doing is using a two-dimensional image that is needs to be textured. So we need to select the texture and go to our texture image. And I'll use the ball particle right there. We're going to sample it using the current time, but there's a bunch of options down here. And if I go through all these, it's going to take quite a bit. But in general, we can either have it play once through the whole thing, we can randomly choose a point, or we can actually split it up and pick several perhaps looping points inside a pre-comp. But let's keep it simple. Let's just use a current time. Now, I can crank up this size. And this really doesn't need a whole lot of particles. Even 20 is quite a bit. Now the particles are disappearing because I have a fairly low lifespan. Let's set this to maybe 12. And just in case we see any of them born inside our comp view, let's go to the particles section and set the opacity of life to do sort of a quick fade on right here. Now with a lifespan of 12 seconds, this is actually still going to be fairly long. Remember, this is dependent on the lifespan of the particle from birth to death. So over 12 seconds, this would be 6 seconds, this would be 3 seconds right here. Right here, this would actually be 1.5 seconds. So we still have a full second fade on going on there. I'm going to add just a little bit of a glow so that this just has a nice subtle glow to it. So I'll add the glow effect, which is under stylize, which you can't see because it's out of frame here. Lower the threshold, turn up the radius. And maybe pump up the intensity just a little bit. Also, I'm going to add a grid to this. So I'm going to select the floor, add a grid under generate. I'll set the blending mode to normal, turn the opacity down just a little bit, and let's make the grid a little bit smaller like that. Maybe turn the border down to 3. Now in the example I showed you, this actually had a reflection on it, so the particles were under the surface as well. Now there's 2 things I could do here. I could actually manually set this up by going to particular, mirroring the emitter position below the floor, setting the gravity to a negative direction, reversing the whole world transforms and all that kind of stuff. Or I could use a very useful script from AE Scripts called Elementary, which is available at aescripts.com/elementary. Elementary works with a number of different plugins. Particular is one of them, and allows us to create things like shadows or reflections, Z-passes, that kind of thing. So if I select my particular layer and my floor layer, I can quite literally create this reflection with one click, simply by clicking on the elementary reflection button right there. I can tell it which parameters to link from my main particle layer, which was this layer right here, and the pre-comped reflection layer. If I'd like to link together parameters such as the emitter position or particle or the physics changes that I could make or the perhaps world transforms, I could do that. It just slows down rendering. So I'll leave these all unchecked and say OK. Now by default this ends up in a multiply blending mode. Now for these colorful sort of glass spheres like this, I'm actually going to set this back to normal, but then I'll go up here to its reflection intensity control. Turn that down a little bit. I'm also going to add a little bit of a blur to this and set this to maybe 12 pixels. Maybe I'll bring that intensity back up. There, now we're almost there. Now there's one thing I need to fix when I do this. Now when I created this floor and I defined the floor layer, there's an automated thing that Particular does, which is create a light called floor. And it's actually kind of a helper light. It's at the position of the floor and the direction of the floor. And it's just something that Particular uses as a reference for position and rotation. And by default, it ends up locked. And in the scripting process, this cannot be brought over into the pre-comp. So what we need to do is go into our pre-comp here, go to my particular layer, go to the bounce physics section, and I just need to define that floor again. So I'll go to physics, bounce, floor, set this to none, and then set this back to floor. And then up here at the top, you'll see that it's again created that floor layer, which wasn't there before. Now, if I go back here, we'll see that the particles are actually bouncing. So we can see, if I turn off this fast blur, we can see this mirror image set of particles. So this isn't ray tracing or anything like that. This is simply a pre-comp that is mirrored and acting the complete opposite of our main particles, using a lot of trickery with Particular, as well as some simple techniques like taking the X scale and actually flipping it backwards. So that's the bounce section of the physics part of Trapcode Particular. So my name is Harry Frank for Red Giant. Thank you so much for watching.